feel like it should almost be called something else than bridging, because I feel like it's so deceptive because it is so different and it is inherently different than what most people know as bridging. And so that's why it's so easy for people to kind of overlook it. But it's incredible. Like interoperability is like the golden goose. It's like the holy grail of innovations in the crypto space, because it essentially enables crypto's version of the internet, right? And so like the amount of things we could do in this space, and this is a big piece of that puzzle. It's not the whole piece, but this is a big piece of that puzzle, and yet not a lot of people are talking about it. I feel like they should be. Welcome to Steady Lads. In this episode today, I interview Hart from Across. Across is pioneering a concept called cross-chain intents. They allow users to move funds between chains, in some cases as little as seconds, and for much cheaper than traditionally possible. Hart is a widely respected builder in the space. He's also built another project you might be familiar with called UMA. He's co-hosted a season of the Blockworks Bell Curve podcast and is overall a pioneer in the space. In this episode, we talk about what are cross-chain intents? How do they work? What sort of use cases do they enable long-term? How soon will they be live? What is the end game for something like Across? How does the ACX token work and what are its use cases? And just a ton more if you're interested in interoperability, what blockchains might look like over the next couple of years, or just the Across protocol itself. This is going to be a really great episode. Let's jump into it. Just to start off, could you briefly introduce who you are and how you're related to Across?
Sure. Are we, we're going now? We're live?
We are live.
Okay, cool. Hey, Jesse. I'm Hart Lambur. I'm the co-founder of Across, and Across is a cross-chain bridging protocol that focuses on an intent-based bridging architecture, which we can get into.
Yeah, can you give like maybe a high-level overview of what is Across, how does it function, and how is it different from a normal bridge? Because I noticed there's like a disconnect with people when I'll talk about Across, they'll be like, oh, that's just a bridge. So can you explain why it's not just a bridge?
We're probably going to need the podcast to go through all the different distinctions between types of bridges and what they're trying to do and all that. But let's start with the fact that Across is trying to bridge value between blockchains. So we're trying to move tokens. So Ethereum from blockchain A to blockchain B. We are not focused on trying to send messages. So the difference here is a message could be like a set of instructions, no real value, or maybe a lot of value associated with it, but kind of abstractly. Whereas with tokens, we're trying to actually just move the token from A to B. And Across is focused on bridging token value.
So maybe to start off with that, explain how a classic bridge works. Like a bridge today, how does that work? And how are you moving value that's different than that?
Yeah, love it. Okay, so classic example here. I want to move Ethereum from A to B. Could be any token from A to B. How do you do that? Like naively, the way you would think about doing this is I'm going to deposit my Ethereum on chain A, and then some magic middle thing is going to happen, and then my Ethereum is going to show up on chain B, right? And this magic middle thing, most of the time, people think about it as sending a message. I'm going to send a message from A to B, and then that's going to be like what bridges my Ethereum between these two chains, and I have it on the other side. Okay, that makes sense, except sending that message quickly, cheaply, and securely all at the same time is very, very hard, if not impossible to do, at least today. Excuse me. Like, it's just a really, really hard problem to send that message quickly, cheaply, and securely. And usually you make a trade-off on some metric, and a lot of the trade-offs here are on security, which is why there's been a lot of bridge hacks historically. Some bridges are very slow to do this, and or there's like a lot of costs. So that's your problem set. So then the alternative approach, the approach we take is like, okay, let's like not do that. Let's actually not send a message. And if we don't send a message, how the hell do we bridge the assets? Well, what we do is we introduce a third party. We call this third party a relayer. Other people in the space, particularly in the intent landscape, would call them solvers or searchers or fillers. This third party goes and they actually fill the user on the destination chain with their own money. So now the flow looks like user deposit, no message gets sent. Relayer races, in this case, to fill the user on the deposit chain. It's not done yet, because again, we need to like figure out how we get the relayer repaid. But at a high level, that's like the architectural difference here, is this third party uses their own money to fill the user on the destination chain. So maybe we'll stop there and like let you push.
Let me see if I understand it right. I'll try to explain it. So from my understanding of how like a classical bridge works would be like, yeah, you're trying to move ETH from chain A to chain B. And let's say chain B is like Solana or like BNB chain or something like that. You're when you're moving that ETH, you're not actually sending your ETH to that chain. What you're actually doing is you're locking up your ETH on the Ethereum side in a smart contract, and you're actually like printing almost a receipt on the other end that represents your ETH that's still stored over on Ethereum. And so that's why we have like these bridge hacks, is because you have these big smart contracts full of all these assets sitting on one side of the bridge, and then the other side you have all these receipts sitting. Would that be like a good way to explain it, or am I off on something?
That is a good way to explain it, although there is like nuance here. Because that type of bridge, there are different flavors. And broadly, I'll say there's two flavors. There's what I'm going to call like the canonical bridge. And then there's like third-party bridges, which are generally called like lock and mint style bridges. So just to go on the difference here, the canonical bridge, and this is like loosely defined, would be if you are a layer 2 roll-up like Optimism or Arbitrum, you have a canonical bridge to move assets from Ethereum mainnet into your rollup, right? And this bridge it's a bit nuanced, but it basically has the security guarantees, the security properties of the chain itself. So like the Optimism canonical bridge is like as trusted as Optimism. And so that type of canonical bridge is quite different from a third party like lock and mint bridge that might have a different way of bridging Ethereum or representing Ethereum. And those bridges, often if they get hacked, they're much more likely to get hacked. And those are the ones that have been like the huge bridge hacks in the past.
So to kind of move forward and maybe focus on the second part of what you said, which was the solvers or the what did you call them?
We'll call them we call them relayers and across, but we'll use the term relayer or solver here.
Okay, so the way that works is somebody is already on the destination chain. So if I'm moving to Solana and I want my funds over there, somebody is already there with like my ETH, right? They're just sitting there hanging out with my ETH already. It's their ETH. And say when I want to move, like, hey, I want to bridge my one ETH over to there, they say, hey, here's my ETH. You can have this. And I'm going to bridge it over myself later, and they get like a small fee by doing this. Is that like the basic?
Yeah. Yeah, exactly. It's there's lots of... We'll come back to examples later, but you're exactly right. So you've got this third party that's like, they're this market maker type person. And Jesse's saying, hey, I want to bridge 10 ETH from Arbitrum to Optimism. You deposit your 10 ETH on Arbitrum, and this other guy or a whole group of people are all competing to win your business, and they compete to fill you on Optimism with their own money, and they send you the 10 ETH. And the thing
it's like Kayak almost.
Sure,
it's sort of like Kayak where they're competing.
You know, there's lots of analogies here in traditional finance markets. Like when you have your Robinhood, I want to buy 10 shares of Apple order. You're going to an exchange, but behind the exchange, all these high frequency trading firms are basically putting up bids and offers to try to buy your Apple shares. So they're competing with each other to be the best price to buy your Apple shares. This is more explicit. This market structure is more explicit in like the way bond markets work or currency exchange markets work. It looks even more like this, but you can think of it as all these market participants are competing to win your business. So we're doing the same thing here with this intent model. And the intent model in general follows this concept of having these third parties compete with market forces to win the business. And so in this case, they're competing to win the business of filling you, Jesse, on your bridge transaction on the destination chain. And they're going to fill it with their own funds. And the reason why they fill it with their own funds is because it's really fast. Like, we don't have to wait for a message. They don't even have to wait for finality. This is like a more nuanced concept, but we don't even have to wait for the deposit transaction on the original blockchain, on the origin blockchain. We don't have to wait for that to be fully confirmed. They could actually, those relayers could actually gamble a little bit and choose to fill you before finality happens, which means it could be like very, very fast. And so far, at least, it's really cheap because we haven't like sent a message. There's been no cost of sending a message. So
got it.
Okay, so then from your perspective as the user trying to bridge, you're pretty happy because you just got this like fast fill and you can move on with your day. From the perspective of the relayer, they're not yet happy because like they just lent a bunch of money, right? But what a cross does is it effectively functions as a settlement service. So the user assets, the user deposits on the origin chain are escrowed, right? And then after the protocol verifies that the relayer did fill Jesse, you, on the destination chain, after that verification happens, those assets get released back to the relayer.
So the end result, kind of like what you said, is that as the user, I want to move my ETH to Solana, and it's just done. Like I click that button, and it's like, I've seen some posts from you where it's like within milliseconds, maybe sometimes like my funds eventually, like long term down the line.
We can do like 2 seconds now if you're coming from Arbitrum or Optimism or one of these like centralized rollup sequencers.
Okay.
I think we can get to 200 milliseconds. And 200 milliseconds is like almost imperceivable. That's like the limits of like humans don't really see things faster than 200 milliseconds. So
yeah, when I move between a website, I'm pretty sure it's like at least 2 seconds. So 200 milliseconds is really, really fast. And maybe for those who don't have the context, maybe there's somebody listening that doesn't always use on-chain. Normally to bridge, it's like 5 to 15 minutes. And it's like pretty expensive to do. And so that like seconds is insane. Like the use cases and the things you can suddenly do, and the way that removes walls between chains is actually game changing because it's moving towards this vision of interoperability, or the idea that like suddenly blockchains can move between each other seamless and with really low friction, because currently there's really high friction to do that.
Agreed. Totally agreed. Yeah. So let's go back to figuring out this solver thing though for a second too. So user is really happy because they have this fast fill. Solver gets paid back after some period of time. And so the question here is, we still wanted to go back to the system being fast, cheap, and secure. And so I think we've kind of gone through why it's fast. Like the solvers just fill the user really quickly. They don't have to wait for a message to get sent. But like, why is it cheap and secure, right? And the question here now goes is like, what we've effectively done is we've separated the urgent part of bridging from like the complex part. So the urgent part of bridging is user just wants their fill done quickly. Okay, great. We've got that part solved. The complex part is, how do you verify what actually happened in this cross-chain context? And intuitively, we can go pretty deep on this, but intuitively, if you have more time to verify something, it's easier to do, or easier to do securely. There's just more eyes on it to watch this whatever you're trying to verify. And that's like basically what we use to our advantage. And the other thing we do is we batch together all these verifications. So if you did your one bridge transaction, but then we have 1,000 other people that are also bridging their transactions in a 20-minute period, we batch together all of those verifications into like one thing. And then we verify that, and we verify it optimistically, which we can go into. But basically, the complex part, we batch over many transactions, and that allows us to make it really cheap because the costs of verifying that get amortized over those 1,000 transactions. And we have just much lower per bridge fees because of this batching and the fact that we can take time to securely verify things. Does that kind of make sense? Intuitively?
Yeah, that makes total sense. So high level, kind of bringing it back all the way through, you are essentially allowing the user to move between chain A and chain B in seconds. using an intent-based model, like the actual asset isn't necessarily moving in seconds. Like like behind the scenes, there's a lot of complexity. Like it's having to get bridged over. There's a relayer on the other side that they're taking on the risk. They're an entrepreneur. They're hungry. They're trying to make some money. They have this business model they built. It's not just one of them, but you have an open market of all these competing relayers who are saying, oh, you actually don't even care how they like get it over. Like, don't
know.
Yeah.
Don't care.
Yeah. You're just saying, hey, like, whoever can get it over the fastest and the cheapest, they're the one that gets this, fee. And so that's all happening behind the scenes. The user doesn't see any of that. They just see, oh, cool, my ETH is on Solana in a second. That's amazing. But behind the scenes, you have this whole process and all these different things that you've built to make sure this is working well, to make sure this is secure, and to build this sort of framework for all of these relayers to come on board and say, hey, we want to participate in sort of like this business model. It's like an app store for bridging, sort of, or an open market for bridging, where there's a lot of innovation that happens because you're kind of pushing the innovation to the edges and allowing all these different builders and entrepreneurs to be the ones to solve this problem on their end and take the risk. Totally.
To give you an example of the way this is kind of operated for 50 years in traditional finance, it would be to go into like the bond market. So like the US Treasury market, which is actually where I started my career, and I traded bonds for 8 years. But the general deal here is if you're like a hedge fund and you want to go and buy 100 million 10-year treasuries, right? What you do is you go and you call up 5 dealers. You ask them, hey, what's your price? And this is effectively, you're requesting quotes from 5 guys for the same trade. And these guys are the relayers in this example. So the 5 dealers are competing, and they're all giving you a price. And then whoever gives you the best price, if you like it, you accept it, and they're done. They've agreed to sell you 100 million 10-year treasuries at whatever price. And in this case, you don't actually care where the dealer gets those treasuries. And in this particular example, the dealer is actually principaling the risk. They don't actually have to have the treasuries. They just agreed to sell them to you. It doesn't really matter. But you don't care where the dealer got those treasuries. You don't care how they came up with their price. You just care about getting the best price. And then behind the scenes, there's a settlement system that settles that. After you've agreed with the dealer to buy their bonds, there's a settlement system that makes sure that you get the bonds and the dealer gets the money, right? Yep. And that takes a while. That actually takes 2 days to actually do that settlement. But if you map it to kind of what we're doing here, it's a very similar concept where the dealer, the relayer, is filling the user, and then there is a delayed period where we're waiting for things to settle to kind of pay back the relayer. But the user gets a fast fill and they can move on with their day.
As far as the fees, for the user to transfer over, you kind of mentioned batching and there's sort of these, well, I guess you don't exactly know because obviously the relayers would be the ones determining the fees. But do you have any sort of idea of what sort of fees it would look like? I know if I want to bridge over funds right now, it could be, actually, I don't know off the top of my head. I guess you would know better than me. What's the normal bridge cost, and how does that compare to this intent-based model?
It really depends on where you're going, right? Because it depends on your gas fees. So this intense model that Across has is so cheap that the actual bridge fees don't really matter. The main fee is the gas costs for the user to deposit their transaction, and then for the relayer to fill them on the destination chain. That's 90% of the fee. And so the way we're trying to architect our system generally, it shouldn't cost much more than if you were just sending assets on the same chain. So if on Ethereum, Jesse, you were sending me assets on Ethereum from you were sending me assets on ETH, we want that to be Across to be basically the same cost. And then there's the cost on the destination chain of me sending you assets. So the cost of Across should be basically nothing more than 2 transfers, 2 asset transfers, one on the origin chain and one on the destination chain. And that is theoretically as cheap as you could possibly make bridging. There is a modest fee on top of that, but we're really talking about modest, pennies.
Yeah, you got to have something for the relayers to compete over. Otherwise, why would they do it? So you're talking for like maybe between two, layer 2 networks, like Optimism and Arbitrum. You're talking a couple cents, and maybe if it's from Ethereum to Optimism, you're talking like depending on the gas fees, cents to dollars.
It's dollars because doing a transfer on Ethereum is still dollars, right? But it's cheap, right? Like. Yeah.
Cheap for Ethereum.
It's cheap for Ethereum. Yeah, that's the right way to put it. Exactly.
So what does this intents, what does it open? Like what sort of use cases I'm sure you've thought it through or thought about it. What sort of things can be enabled by intent-based bridging that maybe we couldn't do in the crypto space before? Yeah,
so this intent thing gets generalized a lot. And that can be useful. But let's step into it. So what are most of these intents? Most of these intents are, my intent is I want to bridge asset A from chain 1 to asset B on chain 2. That's it. That's my intent. Great. I can specify that as here's what I want to do. And I sign a message and then I want to just throw it out into the system to have the market compete to fill me at the best price. Okay. That's the bridging use case. Then you can think about the swapping use case where you're and cross-chain swapping, let's say. I have 10 ETH on chain A and I want the most USDC possible on chain B. And that's my intent, right? I specify this desire. I sign that message and I throw it to the system to have everybody compete to fill me. And I think that also makes a lot of sense. Then the next step would be well, what if I actually really care more about getting the most USDC possible and then depositing it into Aave or some lending protocol or something else like that too. Well, you can include that instruction in your intent order here as well, where you just add it. So I have 10 ETH on chain A. I want the most USDC possible on chain B, and I want to deposit in Aave. And then I sign that and throw it out for the market to compete to fill me the best price. So that's kind of obvious. When you step through it that way, you're okay, cool. That makes sense. What does that enable? If you have 200 millisecond fill times, like I'm talking about, theoretically, or not so theoretically, but you could be controlling another blockchain via intents from your home chain. And this is beginning to abstract away the blockchain thing that we're talking about here, right? So I could literally be clicking buttons for whatever my action was on my home chain. And the intent thing is running an auction to fulfill that action on this remote chain within 200 milliseconds.
Okay. I think I'm understanding what you're saying. So it's I'm on Optimism, but I'm doing things on Solana. Essentially, things are happening, and then the end result's the same thing as if I was doing that thing on Solana, right? Say I want some Jupiter token or something, I don't know, and I'm on Optimism and I'm doing my trading there, but my Jupiter is getting deposited on my Solana address as if I was using some exchange over there. Is that kind of what you mean?
Yeah, exactly. And you can almost think of it intuitively, you can think of this as writing an order ticket. This is, I think, from a traditional finance perspective, makes a ton of sense. Literally, the order ticket is input asset on input chain. It's output asset on output chain, and what you want to do on the output asset chain. And you just fill this ticket out, and then you sign it, and then you pass it off this infrastructure, and you can be assured that the market will compete to fill your order at the best possible price. And when you start thinking about it that way, it's okay, that actually doesn't seem like rocket science, but it also seems like a pretty useful way for us to begin to abstract away chains where you can just imagine a bunch of front ends are filling out these order tickets for you in such a way that you don't even realize what chain you're talking to. It's just doing things on your behalf.
Yeah, because then chains become essentially use cases, right? You might want your assets on Ethereum if you're security is really important. This is $1 billion. I want this on Ethereum. I don't care about a $20 fee. This is $1 billion. I don't want it on, Binance Smart Chain or something. And then maybe you have a chain for privacy and you're like, hey, I want to use this chain specifically for privacy and privacy enabled functions. I use it for record storage or something like that. And so suddenly all these chains could do really specialized different things, and you're able to move between them with something like Intents in milliseconds, maybe one day in the future. And, you can kind of piece together a lot of these use cases to do things that you couldn't do just on Solana, or you couldn't do just on Ethereum.
Yeah. The other example I think is kind of clarifying to think through is like, pretend that you, Jesse, wanted to make like poker chain. So it's going to be its own chain to play poker, right? Yeah. And I bet somebody will do this, or they probably already have, but like somebody's going to make poker chain, right? So it's a layer 2 roll up, or it's its own chain that's just for playing poker. And so you have two ways of like thinking about poker chain. One way is you bridge a bunch of money over to poker chain, and then you start just using that chain. But for your users that have played around with like MetaMask or something, you'd have to like switch networks. You'd have to bridge assets over to poker chain. Yeah. And then you'd have to like switch networks, and then you're like on that chain, and you have to switch networks back, and The other way you could think about doing this, if you kind of think about this intent architecture, is I don't ever bridge assets over to poker chain. I just fill out intents that actually might have assets behind them, but it lets me play poker without actually having to move money over there. So for example, it would be like my first, I ante up. That's like one intent I click, and it moves over my dollar ante to go in there. And then if I want to raise if I want to raise the bet, I click an intent, and it puts over my $50 bet to raise the hand. Something like that. Does that make sense?
Are you saying that, like, I think so. What you're saying is, like, you could be on the poker chain. There's actually no assets on the poker chain, but maybe these assets are over on Arbitrum. And so as you're doing things on the poker chain, it's like sending these intents over to Arbitrum, and the Arbitrum's like, do this on the or with this asset, or do this with that asset. Is that kind of the idea?
I'm not quite saying that. I'm saying that there's assets are basically put onto poker chain in real time. So like literally, like imagine we all have our wallets, like almost like we have like Venmo for an American audience. You can think of like Venmo, and it's like I'm sending a Venmo transaction for each bet I'm making, and like each hand I'm playing, I'm hitting the Venmo button and sending a transaction, and I'm paying my gas fees on poker chain and all that stuff with these Venmo transactions. So I'm in real time putting money into poker chain, such that I don't have to like bridge a pile of money over there and keep it there. I can do it
I
in
see what
real
you're
time.
saying. So somebody else has already brought money over to poker chain. I haven't, but somebody else, who's
this is the part
one of these relayers.
The relayer has money sitting over on poker chain, and they're filling you for a tiny fee. They're making your bets on your behalf as you sign these intents, and then the relayer gets paid back at some later date.
My next question is, how soon will something like this exist? Is intent-based bridging years out, months out? Like, where are we at with this?
So the intent-based bridging is today, like Across is live and like processes 30+ million bucks a day, which makes it one of the most used bridges out there, and it does it.
Wait, so Across today right now uses intents?
Yep.
Oh, I didn't know. I didn't know that. I thought it was that was like something in the future. Okay, so
this is a concept, right? So it's one of these concepts where people talk about this. It's like, how generalized do you want to make it? We actually, like, we're recording this today. We launched Across V3 today, which upgrades Across to use intents in more ways. Like it allows us to do more like cross-chain swaps, and to do we're building something we're calling Across Plus, which is like bridge plus action. So that was the thing I'm talking about, where we could write an intent where we want to bridge an asset and then do something on the destination chain. We're calling that Across Plus. But Across has been intents for 18 months now. Maybe not called that, but that's why it's been so cheap and so fast for the last year or so.
Well, I mean, I'm very familiar with Across because I use usually like a bridge aggregator, and 9 times out of 10, it chooses across. Like 9 times out of 10 when I bridge, it's like, okay, we're going to use across. This is the cheapest and the fastest. Boom. And so that's maybe how my first exposure to across and how I became maybe at first familiar with it as like, okay, it's always choosing across, just another bridge. And then I looked into it more and I'm like, okay, tense based. Okay, what does that mean? But I was thinking this was something in the future, but it sounds like it's sort of more of a spectrum. Like, these relayers and this ecosystem is being built out, but you've already built a portion of it. It's getting better over time, right? Like maybe it's fast and cheap now, but over time it's going to get faster and cheaper.
Yeah, I mean, so Jesse, like this is the part that's pretty wild where empirically, like in the market today, the across architecture has been winning. Like we have all this data and the bridge really is the cheapest bridge, like 9 out of 10 times on the routes we support. We don't support everything. So for example, you've been using Solana and we don't support bridging to Solana yet, working on it, right? But for what we do support, we're really cheap. And the difference here is like, this to me is like empirical proof of our architecture. So our architecture is pretty much the only bridge. Since we've been around, a couple others have sort of showed up doing this, but we're pretty much the only bridge that has this third-party relayer that is filling users. And so this third-party relayer fills users quickly, and then we batch together the verification and do that like on a delayed basis. And this architecture really truly is cheaper than all of the like past message architectures that our competitors are mainly using. So yeah, it's been working well for a little bit now.
I feel like it should almost be called something else than bridging, because I feel like it's so deceptive because it is so different and it is inherently different than what most people know as bridging. And so that's why it's so easy for people to kind of overlook it. But it's incredible. Like interoperability is like the golden goose. It's like the holy grail of innovations in the crypto space, because it essentially enables crypto's version of the internet, right? And so like the amount of things we could do in this space, and this is a big piece of that puzzle. It's not the whole piece, but this is a big piece of that puzzle, and yet not a lot of people are talking about it. I feel like they should be.
Well, I mean, I agree that we should be talking about this more. I think the concepts here, it all depends on like how in the weeds you want to go, right? And it's like proof of work and proof of stake blockchains are very different, but they are both blockchains here.
Yes.
And so at one level, you can talk about moving tokens between blockchains, and doing it with messages versus doing it with intents are very different ways of actually doing this. But end of the day, both do move tokens between blockchains, right? The thing that I find really fascinating is many of our kind of competitors that are focused on moving messages, and I shouldn't even call them competitors because they just do something different. They're trying to like move messages. Their core metric or kind of KPI for success is how many messages they're moving per day. They want to move like 1 billion messages a day. Whereas in this intent model, we actually are trying to like minimize the number of messages we're sending. It's almost the opposite, which I find really funny. It's like we want this model to support 1 billion cross-chain transactions, but like to require like 100 messages to do that. And so it to me is a really interesting dichotomy where we're trying to accomplish the same thing sort of, but the ways we're going about it are quite different. And even the metrics which we are like using to measure success are almost opposite.
What is UMA's optimistic oracle, and how does that fit into Across?
Yeah, so UMA's the first project in crypto I started. And Across is its sister project. It actually spun out of UMA in like a team hackathon we did, looking at use cases for this optimistic oracle. So what is UMA's optimistic oracle? It's actually a pretty simple concept. The idea is we want to get data onto a blockchain in a decentralized way. And we want this to be any type of data. So when people think of oracles, they often think of like price data, which is what Chainlink does very well. But there's lots of other data you want to get on a blockchain, like who won an election, who won a sports game, or in the case we're doing here, did this message happen on this other chain? So like watching other chains is almost like an oracle problem. And so UMA's optimistic oracle works by letting anybody propose something as true. So Jesse, you can use the optimistic oracle to propose like a statement that can be publicly verified. You could be like, Hart wore a black t-shirt on this podcast. And you propose that as true with a challenge period. And provided nobody challenges your statement during that challenge period, it gets taken as true. So what Across does is I talked about like batching together all these relayer repayments. Across optimistically proposes this batch of relayer repayments to UMA and says, hey, all these relayers did in fact fill these users. And then there's a challenge period where anyone can challenge that and say that's not true. And there's like a reward if you challenge this and you're correct. And that's how we're able to optimistically secure this bridge system. And the cool thing about it is it relies on like a one honest disputer assumption. We just need one honest person out there, anywhere on the blockchain, watching this to be like, that's not correct, and dispute it. So that's how the two projects are tied.
What are the use cases of the ACX token?
ACX token is used to incentivize usage of the cross protocol. So we pay out emissions for LPs that provide liquidity to Across, which we can also talk about why Across even needs liquidity. It's kind of an interesting convenience function. It doesn't actually need it. It just makes it work better. And so the general theme here is like Across has done a lot of like smart optimizations that make it cheaper to use blockchains. But the ACX token eventually will take a small cut. That's the idea. Like token holders control a fee switch, very much like Uniswap. And at some point when they think it makes sense, they can turn on a fee switch and earn a small cut of the revenue that gets settled by this Across system.
The legendary fee switch. We've been waiting for that for Uniswap for forever.
You know what's happening, right? There's like... Yeah, so I'm actually pretty involved with the Uniswap team, and I advise the Uniswap Foundation, but their proposals, I shouldn't say it's happening because it all has to get voted on, and I don't know how that's all going to happen, but there is a lot of active interest in figuring out how to turn this on, and so I think it's going to be pretty interesting to see.
Yeah, I think it is. And it'll be an interesting kind of like model to watch because, start out as a governance token, turn on the fee switch. That's like, that we've always anticipated, like, or at least when I look at things, I'm always like looking at the price of something and somebody's like, why is it worth that if it's only a governance token? And I'm like, well, people are anticipating that eventually they'll find a way to like pass on fees in the future. And so this would be the first case of that happening. And I think that would kind of maybe prove that concept out. What long-term with something like cross-chain intents or something like Across, what do you envision? Like, how do you envision maybe Across evolving over time?
Yeah, I mean, so what I look at this architecture as having three layers. There's the layer at the top, which is like the user order. So the user writes their intent. They sign their order ticket. And that could happen in a bridge aggregator, like you talked about using a bridge aggregator before. It could happen in the Across front end, but it could also happen in like any application, any wallet. There's lots of places where users are like creating their intent. And then the second layer is this relayer or solver layer where everybody's competing to fill those intents. And then the bottom layer is like this settlement layer where the user funds are escrowed and then they're released to the solver after we verify the intent gets fulfilled. And so when you think about it from this way, and you think about kind of where value lies, the solver layer looks a little bit like high frequency trading firms, except better because anyone can be a solver, whereas high frequency trading firms have like high barriers to entry. So here we want to have a maximally competitive solver relayer network that is just competing to fill user intents of all types. And one of the things we're working on that I hope by the time this podcast comes out is announced is a standard for cross-chain intents so that we can really standardize how this all works, but have like maximum competition at that level. And it's very PvP, and just like high frequency trading firms are all competing with each other, these guys might have some secret sauce, but it's highly competitive on how they make their money. And then at the top, you have different auctions and different ways of initiating those user orders. And maybe some of those interfaces charge fees. Like maybe a wallet charges a fee, and that's like a business model. And that seems like reasonable. to me too. And then at the bottom, you have a cross as this really cheap and efficient settlement layer for these like cross-chain intents. And if we're this cheap and efficient settlement layer, I think it's reasonable for us to take a modest fee on the value we're settling at some point in the future. And that's what across like ACX token holders control and could turn on.
When you talk about standardizing things with intents, does that mean like opening up the concept for like almost an ecosystem where like other builders come in and maybe build things that you haven't even imagined that like kind of make this system or ecosystem even more functional and fast, etc.?
Yeah, in a sense, it's like, again, I want to figure out how to describe this even better. But when we go back to the order ticket concept, all we're saying is like, it's like, here's the standard way to fill out this order ticket. And any front end, any kind of user touch point can fill out this order ticket that a user signs. But we're trying to make this be a standard, this order ticket. And then once you sign it, you throw it to this like feeding frenzy of solvers that just compete like mayhem to figure out the best way to fill this, right? And that's the model. And so we want maximum competition there. And if we can agree on a standard, we can have lots and lots of people writing these order tickets, which incentivizes better competition because there's more to do for the solvers. So more of them will show up, right? And then the settlement layer here is like, whatever that order ticket is, we need a way to escrow user funds and then verify the intent gets fulfilled. And this standard isn't going to be something that is like across specific, like other people could build settlement layers. But I think we are in the position from our history, and there's a lot of like deep thinking we've done about why we would be really well positioned to be the settlement layer for this cross-chain intent standard. And that's the direction we're heading in the next year.
I love it. When I talk to people about you, I'm not going to call you a bridge. I'm going to call you interoperability powered by intents. That's how you describe yourself. I'm going to describe it like that.
Well, I think we're going to like, I use the term now that Across is becoming a settlement layer for cross-chain intents. I'm not sure that's pretty nerdy, right? But like a settlement layer for cross-chain intents that is running a bridge, like a really successful bridge that is showing how cheap and fast this intent architecture is.
There's something weird in the crypto space where it's like, I don't know how to describe it, but like you can build really amazing products, but for some reason, if you can't get attention, nobody else comes to build on those amazing products. And so it's like two-part, like it's building, but then there is this aspect of almost marketing where you have to like really you have to like get people excited enough to come check it out, where you'll see concepts that I'm like, that's just a normal thing that's been around for forever, but they like kind of phrase it a little different. Then suddenly all these people show up to check it out and be like, this is the greatest thing that's ever existed. And I'm like, that's been around for forever. But then tons of people come and build, and it actually does turn into something maybe unique and interesting that it wasn't before. And so that when I say something like that, I'm like, this is cool. This is really cool. And this is something that I'm excited about. And so I'm glad we're making this podcast so more people can know about what Across is doing, because we need more people building cool things like this in this space. And less people building maybe a lot of attention goes to fluff that is really good at marketing, but isn't really doing anything meaningful to move the space forward.
I very much agree with that, Jesse. I guess the one thing I'd also say is there are kind of two different ways to build here too. And like for us, we started with an idea. We didn't have all of this intent idea stuff figured out. We started with an idea, and then like it was actually intent-like, but we just kind of iterated on it and got better and better and better. And then we kind of like started doing really well. And so it's an interesting position where we didn't have all of these like crazy cool concepts all articulated well 18 months ago. We just started building, right? And there are some other projects that are quite different where they like really articulate their concepts well. Like Eigenlayer is articulating this really interesting concept well, yes. And then they're going to launch it, and it's a different path. And like, look, just there's different paths here. And I do feel Eigenlayer, by the way, I don't think has bad marketing. I think they have great marketing because they're a really interesting idea. But there are other projects out there that I very much agree with you on that are just a bunch of fluff and a bunch of like...
Yeah, it's hard because most people in the space don't understand anything. Like 99% of what is happening, they don't understand. So when you throw a cool new word in there and it's a new project that's launching and a lot of people are talking about it, they just assume it's revolutionary without actually understanding why it's revolutionary. And I think that's why it's so easy to trick people into being like, oh, this is an amazing thing over here, is because, this is an AI-enabled, interoperability, blah, blah, blah. And people are like, whoa, that sounds really important. Plus, it's a new token that just launched. So it must be amazing. And I think some of that also the new token comes from actually a good place in that 2017, I'm sure you're around 2017, all those projects were like just hot garbage. They had the coolest names. They had really good white papers. And that was about it. They didn't do any building. And then 2021, you had all these people come in and they built real products. And suddenly people were actually going on chain and using things. And it was like, whoa, this is crazy. I can swap on chain. I don't have to swap on Binance. This is wild. And so then you had this new batch of like real builders. And so people, I think in this new 2022, or sorry, it's 2024. Oh my gosh. People in 2024 they have sort of this PTSD of like, okay, the new batch of tokens are going to be worth more because that's what happened last time, without taking into the factor that like the last batch of projects, there was actually some really good builders that built real products that are good. So I think I think the market is still sorting that out, but I think that they will. I don't think it's going to do that for forever.
I do hope you're right. Because you're talking to a guy that like the UMA project is something that we are innovating hard on. We just launched a new project called UMA, or a new product called UMA Oval, that I think is a really cool meta capture thing for Oracle projects, for Oracle price feeds. And it actually, bizarrely, it has many, many parallels to the Across infrastructure. The UMA optimistic Oracle is powering prediction markets like Polymarket. And I think this whole idea of trying to find truth in a world of like AI and fake news is like a big deal. But like, to be fair, a lot of projects that were around from 2018, 2017 are not really around anymore. And there are a few exceptions, and I like to think we're one of them, that have been consistently doing things for a long time. And I do believe that the market will reward that at some point. Too. So,
I think so too, because you had Bitcoin at first, then 2017 cycle, that's when ETH really kind of stuck and people were like, okay, this is actually, even in 2019, people didn't know if ETH was coming back. People were like, okay, is that dead? And then it came back, and then it's like suddenly Bitcoin and ETH. Those are the ones that like multi-cycle. Those are the assets. Those are the projects that have momentum. But now I think in 2024, we're going to have a new batch of like things, a lot more. Like it's not going to be 2, but we're going to have like 30, different projects that stuck around from the last cycle that are like, okay, these are real builders that have built real innovations, and they kind of carry forward every cycle until we get to a point where there's so many good projects that people are going to feel kind of dumb gambling on a brand new one, because it'll become like the opposite, because they'll have seen so many that like just fail and just die that it becomes too risky for a lot of participants. It's just, the market's still a lot of maturing going on. What are you most excited about over the next few months when it comes to Across?
This intent framework, like the settlement layer for intents, there's so much nerdy shit we're doing on optimizing auctions, like decentralized auctions, to have like better pricing, and like even better fills, faster fills times. There's a lot of just kind of like iterative improvements that'll get us closer to being ridiculously cheap and ridiculously fast interop layer for these intents. But then the idea is, if we have this intent standard, can we get a lot of applications actually adopting it in ways that we didn't particularly like fully imagine? That would be wild. And then can we get Across as a settlement layer for intents to support all sorts of different chains too? Like, can we actually have pretty good coverage in this world of 1,000 rollups and a whole bunch of app chains?
When do you imagine, you said 200 milliseconds, that's like your goal, or somewhere around there. When do you imagine that'll be possible?
We are not that far off in some contexts, right? It will never be possible if your origin is Ethereum. It will never be possible if your origin is Ethereum mainnet until we have like single slot finality on Ethereum, which is like a 5-year out thing, right? So, there's stuff there. But on some of the centralized sequencers, getting us to sub 2 seconds, like we're already there at 2 seconds. Getting much cheaper than that also depends on the block speeds of the L2s themselves. And so we need them to get faster, but we're not that far away.
What other maybe things or projects in the space get you excited right now? It doesn't have to be about intents or interoperability, but like, what are you seeing in the crypto space? And you're like, wow, that's crazy. That's so cool. I'm stoked about that.
I am really interested in MEV capture stuff too. So stuff that captures different podcasts that go into like the MEV supply chain. But I'm really interested in that stuff. Our project, like Uma Oval, that's doing MEV capture for Oracle updates, is very much in that space. But CowSwap, you mentioned CowSwap. CowSwap is MEV capture for DEX trades. I think that's really interesting. There's some other things being built around Uniswap v4 that I think are going to be super cool there too. So it's kind of like, and I think this idea of MEV capture is actually going to be a growing narrative where if we can capture MEV, it becomes a new revenue stream to build business models around, which I think is a really interesting idea. And then on the other side of the other thing is eigenlayer. Like I do think eigenlayer is a really fascinating concept. I think right now a lot of people don't fully understand. It's become a marketing meme, not by any fault of the eigenlayer team. They're the most credible team out there. But I don't think a lot of people really think about like how it works or what it does. But when you dig into this idea, there's a real elegance to it. There's some real scary stuff too, because I do think there is some added risk factors. But I think it's inevitable, and I think it's quite interesting.
Yeah, I think when I talk to most people about eigenlayer, they think immediately about the extra yield. So they're looking at it and saying, hey, cool, I'm going to be able to stack up my ETH yield to like 1,000%. Is that what's going to happen? And I don't think most people actually think about like, why does eigenlayer exist? Like, what is the function of eigenlayer? Very few have kind of like dove into that, I think, in the wider space about like, okay, cool. What does this enable? Like being able to tap into like Ethereum's core security and using that to secure or create other things. And like, what can we do now that it's like you can spin up a layer one with these similar security properties and have it be like really easy for somebody to do that. And they no longer have to bootstrap it and like do all these subsidies and stuff. I mean, all kinds of cool things. I think it speeds up the ability for builders to build more infrastructure faster. And I think the whole space is just going to start moving forward a lot quicker. I'm with you. That is really exciting.
Yeah, but I will, like, for all your viewers that are excited about yield, like that's where they should be afraid, right? Like you don't get a free lunch totally. You can optimize stuff, but your yield, there is risk involved definitionally, right? And I think that's the part that I think is unfortunate is human beings generally are very bad at pricing risk, particularly tail risk. And so that's where people get hurt generally.
Yes, I'm with you. I try to figure out where the risk is with the yield. With Sriram, he thinks that the yield is just not going to be that high. He thinks because of the way it's built, that the yield may be like 8%, 12% or something like that. I kind of think to start out, there's no way that happens. I think it's going to be nuts when it first launches, and the yield is just going to be out of control. Because I don't know. I feel like, I mean, look at the Cosmos chains. They do like 10% yields for like their validators. And, if they could drop to 1%, that's a pretty good savings.
Well, put it this, here's where I'd push back. So let's assume Eigenlayer does pretty well and it gets a lot of stake in it. And I think it already does have a ton of stake in it. But let's say they have $100 billion of Ethereum staked in Eigenlayer. A 10% yield means you're paying $10 billion. Where's that money coming from? Like $10 billion in fees is a lot. And, that's where I'm like, I tend to agree with Sriram. Like you do the math and you're like, okay, well, there's just not that much juice to go around.
I agree long term, but what I'm saying is when it first launches, that's when I think it'll be like Ponzi season almost. Not that it'll be a Ponzi, but like it'll be like this incredible. It's kind of like when DeFi summer happened. You know what I mean? Like the yields were just out of control. Some of that was just like bad tokenomics. But I think it's like any new project when it launches, the yield's really, really high. But then suddenly people are like, oh, that's really high yield. So then everyone piles in, and then the yield's really, really low. And so
we'll see. The thing that I just don't know is I don't know how the eigenlayer token is going to work. So that's the part that I think people are going to be quite excited about.
Yeah, we'll see. Well, I guess if people want to follow along with Across and you and everything's going on, where's the best place that they can go?
So you should follow me personally on Twitter at HAL2001, HAL2001, or on Farcaster. I'm at Hart, just my name. Although I'm not on Farcaster that much yet, but getting there. And then for the Across project, the domain is across.to. You bridge across.to, another chain. And on Twitter, we're at Across Protocol. And yeah, we're doing a lot right now. I think some of the intense standard stuff we're working on are gonna be big announcements. And we're just really pumped about our positioning in this interop landscape. So yeah, Jesse, thanks for having me.